Hello friends, welcome back to Comparative Physics. This is Afsal. In the last class, we have learned the concept of speed and how to calculate speed using equations. We looked at the numbers, did the division, we got the answer. But let's be honest, simply starting at a list of numbers can get confusing. If I gave you a whole page of data, you would get lost. There are better ways to handle data in physics. We don't just read stories, we draw stories. And my dear friends, today we are going to learn how to translate a physical event into a picture. We can call this picture a distance time graph. This is one of the most important tools in physics to understand and analyze a problem. So please do focus here. I'm not going to start with usual rules. I'm not going to draw some random lines on the boards and tell you to remember this or memorize this. Instead, we are going to learn the concept behind the distance time graph by using a simple story. This is a story of a student named Ali and his chaotic morning. Let's say this is the situation. Ali walks from his house to the bus stop to catch his school bus. He starts walking in a nice and steady pace. He walks for 40 seconds to cover 40-meter distance from his house. See, we need to make some important notes of the stories, so that we can easily plot the graph by using these 2 to 3 important notes. We don't need to memorize the whole story. Parallelly, we need to draw the story to get the physical feel of it. Let's say, see, this is Ali's house. Okay, let's say this is Ali's house. Ali's house. He started walking from here through this path. And this is the 40-meter mark. Right at this point, he sees his friend and he stops there. Let's say this is Ali. Let's say this is Ali and this is Ali's friend. As I told you, we need to make some important notes of the story. So the first note I am going to make is the walking event from his house to this 40-meter distance. Let's say I'm going to name that event as walking. Okay, let's say this is the walking event. In 0 to 40 seconds, Ali covers 40 meters of distance. Right at this 40-meter mark, he met his friend. He stopped there and took 20 seconds for chatting. So the second event is the chatting event. What is that? The chatting event. For the next 20 seconds, he covers 0 meters of distance. Why? Because he is simply standing there and talking to his friend. He is not moving. So the distance covered in the chatting event or in 20 seconds is 0 meter. Right? Now, after some time, Ali realizes he forgot his homework at his home. He panics, turns around and runs back to his home to pick his homework. This is the third event, that is the running event. What is that? The running event. See, because he is running, he is much faster. So he covers the same 40-meter distance back to his house in just 10 seconds. See, this is in 10 seconds, he covers the same 40-meter distance, runs back to his house. So the story ends here. Now we need to plot or translate these 3 events into a distance time graph, that too in data, because ultimately we need data to plot any graphs. That is why I purposefully picked all the data from the stories to make 2 to 3 important notes. Now we can draw our figure. Let's say this is our y-axis and this is our x-axis. In x-axis, I am going to take time taken by Ali, and in y-axis, I am going to take distance covered by Ali. Okay. So first of all, you have to plot the walking event, then chatting event, then the running event. Before plotting this walking event, we have to plot the initial position of Ali. Initially, where was he? He was at his home, right? When he was at his home, he didn't start to walk, so the distance covered is 0 and the time taken is also 0. There is only one point in the distance time graph where both the values distance and time is equal to 0. That is this point. At this point, time and distance is 0. So this is the point which is exactly equivalent to the position of Ali's house. Remember one thing, these 2 points are not equal, these 2 points are equivalent to each other. Now we can easily plot the first event, that is the walking event. How much distance he covered? 40 meters he covers in how much time? In 40 seconds. Let's say this is 0 meter, and let's say this is 10 meter, let's say this is 20 meter, this is 30 meter, and this is 40 meter. So this is the 40 meter mark. Okay, then in time axis we need to plot, this is 10 seconds, this is 20 seconds, and this is 30 seconds, and this is 40 seconds. So to plot the walking event, we need to mark the 40 meter distance. This is the 40 meters distance in the distance axis. This is the 40 seconds in y axis. Now we need to plot, we need to translate the physical 40 meter mark point into this distance time graph. For that, we need to coincide these 2 points. What are their points? 40 meter distance and 40 seconds. So now I'm going to find that point. See, exactly right at this point, these 2 points, 40 meter and 40 seconds are coincided, which means this is the exact equivalent point which is equal to the physical 40 meter mark. Now we have plotted most important 2 points, the initial position of the Ali and the 40 meter mark point in the distance time graph. Now we need to translate the path followed by the Ali into this distance time graph. But remember one thing, in physics, we are not interested in the shape or size of the path followed by the object, but we are interested in how the object is moving through the path. Like, is he maintaining a constant speed or variable speed? Like that matter we are interested. Now we are going to assume Ali maintained a constant speed throughout this 40 meter distance up to the 40 meter mark point. We can represent any constant speed in distance time graph by using a straight line. So we got the path. How we can represent the path of the Ali? The actual path is like a curved one. Now we can represent that actual path in distance time graph by using a straight line. So this is the end point of the walking. This is the starting point of the walking. So we need to connect these 2 points by using a straight line. For example, this is the path. Now we have easily converted the initial position, final position, and path of the Ali. So the first event is completed. Now we can jump on to the second event, that is the chatting event. This is very simple. For that I just need to, let's say this is our time axis. Okay, up to this the time is here. Okay, now we need to translate the chatting event. So in 20 seconds, the distance covered is 0 meter. See, which means Ali is stationary, Ali is not moving. We can represent any stationary event in distance time graph by using a simple horizontal straight line. So that this is, let's say this is the horizontal line. Okay, let's say this is the horizontal line. And we can represent this is the chatting event. Please take a look at the initial position of the chatting point. This is the initial point of the chatting. At this point, the distance is 40 meter. And let's say this is the final position of the chatting point. At this point also, the distance is 40 meter, which means the distance covered in this chatting event is 0. It only, here the time is only running. Time is running up to what? Time is running. Here the time is running. How much time he took for the chatting? Just 20 seconds. So this is 40 seconds plus 20 seconds. We will get 60 seconds. So in 60 seconds, the chatting ended. Now we need to plot the final event, that is the running event. Remember, because he is running, he is much faster. So he took only 10 seconds to cover the same 40 meter distance. See, the running event starts from this 40 meter mark and ends at the Ali's house. So in graph, this is the end of the chat. This is the end of the chatting event. At the same time, this is the starting of the running event. So where the running event ends in the distance time graph. That is, we need to plot. We have the initial position of the running. So in running event, he covers 40 meters of distance in 10 seconds. So we need to add another 10 seconds to the 60 seconds. So 60 plus 10, this will be our 70 seconds. So this is the final position of the Ali after running. So we have the initial position. This is the initial position of the running, and this is the final position of the running. This is the 40-meter distance. Right? This is the 40-meter distance. So because when he is running back to him, when he is running back to his, he is covering same 40-meter distance. Now we need to cover. See, we need to plot a straight line in between these two lines. So this is the running line. Done. The story is finished. We have completely translated the whole story into distance time graph. But this is not a big thing. Everyone can draw this distance time graph if the story is given. But now we are going to unlock the beautiful concept which is hidden in the distance time graph. How? By simply looking at the distance time graph, how we can spot easily who is faster and who is slower. Now we can easily say, because as I already told you, this is the walking line and this is the running line. So this line is much faster than this line. You can easily say, because you have the whole story, whole data, everything is here. Imagine if the story is not given to you, only this graph is in front of you. Then how do you identify? By simply looking at the graph without any single calculations, how can you spot who is faster and who is slower? That is what we are going to learn today. This is the most important concept of distance time graph. See, now we are having 4 persons. These 4 persons are going to cover 40-meter distance in different ways. For example, this is the distance time graph. I have plotted the distance. I have marked the distance in the distance axis and the time axis. All these 4 persons are going to cover same 40-meter distance. So here the distance is fixed. So I am going to fix the distance. Let's say this is the distance. Okay, I'm going to fix this distance because this distance is same for all the 4 persons, but only time is varying because here all the 4 persons covering these 4-meter distance in different ways. For example, the first person who is going to cover the 40-meter distance by simply walking, like our Ali. So he took exactly 40 seconds to cover the 40-meter distance. So this is the initial position. See, this is the initial this is the this is the initial position of the person number 1. Now we have this is the 40-meter distance. Now we need to coincide these 2 values to get the exact point. So this is the final point of the walker. This is the initial point of the walker. Now we can easily plot this line. Okay, this is the line which is representing the walker. The second person, he is a runner. He is completing the 40-meter distance by running. Because he is running, he is faster than the walker. So he covers the distance in, let's say, in 20 seconds. See, this is the time. Let's say this was the time. 20 seconds. So we need to plot that point. Let's say this is the final position of the runner. This is the initial position of the runner. We have the 2 points. Now we need to join these 2 lines by this line. So this is the line of the runner. Now the third person, who is a cyclist, who is covering the 40 meters distance by cycling. So he is cycling, he is much faster than these 2 persons. So he covers the 40-meter distance in, let's say, in 10 seconds. So we need to find the final position. This is the final position. This is the initial position of the cyclist. So this is the line. And there is another 4th person. He is very lazy. So he covers the 40-meter distance like a turtle. He is very slow. So he took almost 80 seconds. Let's say this is the 80 seconds. 80 seconds to cover this 40-meter distance. Now we need to plot that. So this is the final position of the the person who walks like a turtle. And this is the initial position. Now we need to plot that. See, this is it. Very simple. Now we have plotted all the 4 lines, of all the 4 persons. Now we need to find out the speed of each person. So it will be very easy to assess the lines. Okay. See, let's say the speed of the, let's say this is the stroller. Speed of the stroller S1 is equal to simply distance by time. Distance is same for all the 4 persons. What is the distance? 40 meter. What is the time? That is 80 seconds for the person who walks like a turtle. So this is 80. So 40 by 80 is 0.5 meter per second. So the speed of the stroller is 0.5 meter per second. Then I am going to find the speed of the second person who walks like a normal walker walks like an alley. So the distance by the time to distance is 40 and time is also 40. 40 by 40, 1 meter per second is the speed of this walker. This is 1 meter per second. And I'm going to find the speed of the third person, that is who is a runner. Distance divided by T3. Distance is 40 meter. Same for all the persons. Time to by the runner is 20 seconds. So 40 by 20 is simply 2 meter per second. So the speed of this person is what? 2 meter per second. Then the final speed, that is S4, is equal to simply distance divided by T4. That is simply 40 divided by T4 is 10 seconds. So 40 by 10 is equal to 4 meter per second. See, this is what? 4 meter per second. See, now I want you to carefully observe the pattern of these 4 lines. See, when the line is getting closer to the distance axis, the steepness of the line is also increasing. When the steepness of the line is increasing, the speed of each line is increasing from 0.5 to 1, then 2 and finally 4 meter per second. Do you know what I mean by steepness? If a line looks more steeper, means the line looks more vertical. If the line looks less steeper, means the line looks more flatter, which means the line is getting flat, the line is getting closer to the time axis. If a line is getting more vertical, means it is getting closer to the distance axis. Now the golden point you have to keep in your mind is, the faster you are, the line looks more vertical. The slower you are, the line looks more flatter, which means the line is getting closer to the time axis. Now we have clearly understood the concept behind the distance time graph. Now we can easily read any distance time graph without any calculation, without any story, by simply looking at the steepness of the by simply looking at the steepness of the line. We can easily spot who is faster and who is slower. But when you write for your exam, you have to use a proper technical word. In physics, we have a proper technical word instead of the word steepness. Steepness means, in physics, the word steepness means gradient. What is gradient? That is high steepness. Okay. Steepness means high gradient. High gradient or steep gradient, which means high speed. Which means high speed. Then gentle gradient. Sorry, gentle steepness. We can call it as gentle gradient also. No. Gentle steepness means low gradient, which means low speed. Now the third point is flat line. Flat line means zero gradient. Zero gradient, or the object is under stationary. Right? This is the main 3 points we need to keep in our mind when we are going to read a distance time graph. Now I just wanted to test you one thing. Imagine if your superhero Flash would cover the same 40-meter distance in 0.0001 second, then where would be his line in this graph? And if a snail is covering the same 40-meter distance in 100 years, all these are imaginary situations, in 100 years, then where would be the line of the snail in this graph? Please comment your answer in the comment box. If you like this class, subscribe to the channel and do share with your friends. And I will see you in the next class.